During this session, I would like to share a bit the journey that we have been on at Swift, exploring confidential computing capabilities in the scope of preventing fraud through secure industry collaboration. Let's see if I can move the slide. Yep. But first, a little bit background of who is Swift. We are the largest provider of global financial messaging services, enabling trade, payments, and security transactions. On our network, we connect over more than 11,500 endpoints over in 200 countries. And behind that, there are more than 4 billion accounts that can make cross-border payments over our network. On a daily basis, we process more than 40 million messages, and every 3 days we process the world's global GDP over our network. So we are truly the backbone of the global economy, and we are trusted every second and every day to make this happen. Looking at the problem of fraud, studies have shown in 2023 the total cost of fraud to the global economy was nearly $500 billion, and this figure keeps going up year on year. It's a truly global problem. It's almost equally spread between the Americas, EMEA, and APAC. It is clear fraud doesn't stop at the border, but fraudsters operate at a global scale. And I see three main reasons why it's so challenging to prevent fraud in payments. There is a lot of good innovation happening in the payment ecosystem with new capabilities coming, but I also have some side effects. For example, there is a strong move now to instant and near real-time payments, but unfortunately, in some cases, an instant payment may also mean instant fraud, and once the funds are in the receiving account, they can't be recovered. The second driver is fragmentation in the ecosystem. These days, there are more and more ways and approaches to make payments. You have the classical account-to-account payments, but also wallet-to-wallet on smartphones. You have embedded payment capabilities in commercial websites, and you also have the whole world of crypto and digital assets. So there are so many more new ways and rails to move value these days. And fragmentation also leads to weaknesses. And the third key reason is data lives in silos, starting within banks, certain departments not talking to each other, and then between financial institutions, very limited ways to collaborate on data and sharing insights. And for fraudsters, they don't stop innovating. These days, they're also leveraging Gen AI to create deepfakes. And I also read recently on the dark web, frauds as a service is now also being offered. What we are seeing is, though, that financial institutions are starting to collaborate in so-called private-to-private information sharing networks to combat economic crime. From a Swift perspective, we are for many years a sponsor of the Future of Financial Intelligence sharing research program led by Nick Maxwell. And in 2020, he did this survey, which you see here on screen, where he's surveyed 15 of such initiatives where banks are coming together and sharing information. And we see very good results. For instance, here in the US, 5 times more true positives, so true fraud cases that should be reported to financial intelligence units. In the Netherlands, 85% increase in time saving to detect money laundering patterns. And in the UK, in the experiment with with three banks, over 1.4 billion in pound sterling could be avoided in 1 year. So truly, you need to create a network to fight a network. And it's with that in mind that in 2023, SWIFT has created its own industry pilot group, bringing together the largest banks on our network to collaborate and explore and innovate together. How can we enable more of such private information sharing networks? And we are particularly proud we have banks here from the Americas, strong representation in Europe, but also APAC, Africa, and Australia, all working with us and exploring this together. And under the program, we have four key work streams. Last year, we spent a lot of time exploring use cases and go through a business design phase. We are also partnering with Deloitte to understand the legal and the regulatory landscape. In the first quarter this year, we spent a lot of time on concept validation, leveraging confidential computing and artificial data to demonstrate the capabilities to our customers. And our ambition is later in this year, we would like to truly establish the business value that we can create with these use cases and redo these experiments with real data from our financial institutions. So looking a bit deeper now in each use case, the first use case that was selected is fraudulent and mule account sharing. And that's what you see here on the slide. And the use case is a fraud team in a financial institution A at the top left, as they are transaction monitoring the payments that flow through their system, may get a suspicion about a beneficiary account that is held with another financial institution, that something suspicious might be going on there. But that financial institution doesn't own the account, they don't know the customer, so they can't make a determination on that. So they can flag that account into a collaboration space, which is then operated by SWIFT. And then the institution holding that account, financial institution B at the top right, then gets a notification that one of its accounts is marked as suspicious, starts an investigation, and that then leads to either a confirmation that indeed fraudulent activity or money muling is ongoing, or they could deny it and conclude that the account is in good standing. That investigation might take a couple of days to complete, and meanwhile, financial institution C, as it is processing new payments, would like to check that any of those beneficiary accounts is listed in this collaboration space, so they could get a warning that it's marked as suspicious and an investigation is ongoing, or they could also get an answer that it is a confirmed account used by a fraudster or a money muler. The second use case that was selected is around AI-driven anomaly detection. I spoke about more and more payments become instant and near real time, so it also means that the transaction monitors need to be able to work at high speed and high accuracy to truly find the needles in the haystack. And the idea here is that we could start from training an AI model on the entire SWIFT network data, the full cross-border view of payments, and then through a federated learning network, send that model to each participating bank, where that model then further trains against their own data and their own historic fraud labels. And the idea here is that fraud teams in financial institutions will have many more examples of historic frauds that have happened, more than SWIFT ever can see. And so the goal here is really to create a truly network effect. If each bank contribute their own insights to the model, then collectively as a consortium, we all benefit from the outcome of that. So it's truly creating a consortium model trained on consortium data, but without having to move the data to a central location. I talked about that we, of course, also keep a close eye on the legal and the regulatory landscape because we can build the most secure architectures, but at the end of the day, we do need a legal and a lawful ground to operate. But the good news here is, again, illustrated through a study by FFIS, that a lot of innovation is happening even at the policy making and legislative authorities. And certainly in the last decade, the United States, Mexico, Canada, Singapore, Europe, and recently also Australia, all have passed legislation supporting financial institutions come together, collaborate on data when certain risk thresholds are passed, obviously whilst preserving the privacy of citizens. And moving on to the third work stream that we are looking at, concept validation. At the start of this year, we partnered with colleagues at Google Cloud and a company called Data Village, headquartered in Belgium and specialized in trusted data collaboration, to implement a prototype with artificial data to illustrate to our members of the industry pilot group of how we could implement mule account sharing. And on this slide, you can see the architecture. You can see the architecture that was used, which consists about centrally a control zone and a collaboration zone operated by SWIFT. And each financial institution can connect their IT back system. They choose their own key management system and a storage account that they will use to exchange data with the collaboration zone. And the process is as follows. SWIFT connects to the control zone, creates a collaboration project, invites financial institutions. They get an email and then accept to enter the collaboration project. So in this case, the mule account sharing use case. SWIFT then, via the control plane, automatically deploys the business logic in a confidential compute or a trusted execution environment, fully automated, no human in the loop. And that's what you see here on the right-hand side, which the business logic will manage that account list. Banks then can connect their IT system to the control plane via the API channel and start interacting. They provide, for instance, the suspicious account list in their storage account. The collaboration zone will read that encrypted data from the storage account, then request the decryption key from the key management system, and in order to pass that key, will go through an attestation process. So from a financial institution perspective, you get a guarantee that the collaboration zone is running in confidential compute on the specified hardware, the specified software, and that the data is correctly protected. Then the collaboration zone can decrypt that data and execute the business logic. Part of that business logic and part of SWIFT's role is to validate the data. So there is also a agreed data contract to make sure that the schema, the formatting, and any logical checking that we can do on the data is correct. And any output from the collaboration zone back to a financial institution is encrypted with a private key maintained by the collaboration zone. And the financial institution can then use a public key to decrypt that information. I also should have explained when the decryption key between the financial institution and the collaboration zone is exchanged, also that is protected with a public-private key pair. And then finally, as I explained, financial institutions C can query this utility through an API channel as it's making new payments and validate the beneficiary accounts. Every API call is also fully protected by a public-private key pair associated with that collaboration zone, just to make sure that no one can see which queries are being made or which results are passed back. Then for the second use case, we partnered again with colleagues at Google, Rhino Federated Computing Platform, which specializes in enabling federated learning, Capgemini as the integrator of that platform on Google Cloud, and underneath in the Rhino platform, we relied on NVIDIA Flare as the federated learning framework. And one reason also for us to partner with Google was not only about the cloud computing capabilities, but also originally Google was the inventor of federated learning. So it also gives us access to that expertise. And then again, on this slide, you see the architecture that we use to demonstrate this to our member banks. And again, in the first phase, using artificial data. And you see here the three layers. So at the bottom layer, the client side of the federated learning network runs within a zone fully controlled by a financial institution, where you have the Rhino client, which manages all the communication with the Rhino cloud. Then you have the Rhino cloud itself, which operates as a SaaS solution. So in here, Swift has its own tenant and operates the federated learning server part to create the global model. And then at the top layer, you have the UX and governance layer again, with also the API channel to allow integration and automation. And some of the key aspects here are that the federated learning server, as well as each client node, runs in confidential compute, and that whenever secrets are exchanged between the server or the client, again, we go through an attestation process, and we use encryption, and we provide encryption keys. So, for example, the data scientist from Swift will create that global model, encrypt it, store it in the artifact registry, and when that model moves from the server to each client, the clients will request a full attestation of that Docker container, and before Swift releases the decryption key to each client node, it will also ask an attestation from the client side. So we also get confirmation that the financial institutions are running in confidential compute with the software that was agreed. And maybe a last important security feature that we are validating is as the client nodes exchange their trained weights and parameters back with the server, is to use fully homomorphic encryption, so that this calculation actually happens in a fully encrypted space. And so from my side, experimenting with these technologies and these approaches, what I'm starting to see is that this technology is becoming mature to create security and privacy at scale. As I showed in the intro, we operate in over 200 countries, and we connect over 11,500 institutions that we want to be able to reach. So leveraging cloud and be able to scale over the cloud is important, but as we build this technology stack, we would like to remain cloud agnostic so we can get truly global scalability without vendor lock-in. And thinking about this architecture, as we have been discussing today, you can really build a very layered architecture. These technologies are still very evolutive, and by building a layered architecture, you can still swap in things that layers in and out as the technology evolves. But at the bottom, you have your confidential compute platform, which you can get from any cloud provider, leveraging Intel, TDX, AMD, and so forth. On top of that, you have your operating system, so you can use cloud, Kubernetes, or edgeless systems, as we have heard today, and there are other flavors available. On top of that, you have your attestation service, and there also multiple choices are available. You can rely on cloud-provided attestation services, as well as Intel's project or NVIDIA. Also, Red Hat with OpenShift is looking at attestation services. So these are all choices that you have. And then on top of that, you can either go the route of confidential AI on centralized data with the classical libraries like Python, or a federated way where you can have NVIDIA Flare, Flower, and Intel's OpenFL, for instance, or Google's federated TensorFlow. And then on top of that, what Data Village and Rhino are bringing is the whole stack of infrastructure, optimization and orchestration, the orchestration of the platform, and then ultimately on top your UX and governance. But you can see that similar architectures are starting to appear and similar approaches. So then as a final slide, coming out of this exercise with artificial data, getting our members of the industry pilot group excited of what's possible. Our ambition now later this year is to hopefully be able to repeat these experiments, leveraging real data from our financial institutions, and really prove the business value that we can generate either through mule account sharing or fraudulent account sharing on one side, or on the other side, sharing of fraud information, historical examples of fraud to enhance AI-driven anomaly detection. And the goal for us is really to quantify how much more benefit and how much more fraud we could prevent by using these technologies.